document here. As I said, the thing is that, you see, this one says, section 6 says combined estimate, but I already have combined estimate up here. So I forgot to remove section 6.
Okay.
So we're only dealing with section 4. So let's see. Maybe we can look at your code together. So what was everything that was done with the A estimator?
Okay. Yes, we have the A estimator and the logging of the estimator.
Right. The logarithm estimator is almost the same.
Yes, and I do this in the document that I outline in the Dropbox.
Okay, good. So I can open that. Now let me correct this because this equation is not correct here. I always have to make some corrections. This here is not. These subscripts here are not correct. It should be. Let's see. Oh, that's this one. Okay, I need to go here. It's this one here. This is not correct. This one should be gamma. And then this should be Zn. And then gamma Sn. It's just some notation. I don't really change the equation, but I think this notation is better. Okay, so let me open the other one. So I have to open my Python. That's not what I want. Or let's see, I want. And we will go to Spider. And then I will go to the new one. Whoops, should be over there. Okay, file, open. Let's see if it's here. Should be, no, it's not. Well, actually, I can go here, and then I'll go to the new one. It should be here, here, and then here. No, consistency.
Inconstant.
Yes. Okay. And then.
Yes. New simulation current.
Okay. Yes, that's right. Okay, good. Okay. All right, good. So let me just run first and see what's going on. Okay. All right. Now, let's see. I think you changed many things because I put all of the functions into a separate file. So I think you're basing this on an old version. Let me see here. If I go here, I put the functions in a file here. So I think you're using the old version here.
Yes.
I have a newer version. So let me recover my version because I think it overwrote the other one. This is why you need to work in Dropbox. You're not working in Dropbox. You need to work in Dropbox. Otherwise, we will always have this problem that you will do some file and I will do a different file. So you need to work in Dropbox.
Okay.
And not work in another file and then change. Because otherwise we will have this problem too many times. So let me go back here. And I will open the previous version. It should be down here. Right. So here we have this. It looks like it's this one here. So I'm going to download this. Can I download it? Let's see. It should be this one here. Or I guess I have to do this one here. Because I don't want to restore, it must be, just a moment. No, it's not going to let me do this, so I'll do this one here. Save as. No, it's not that. I think I have to click here. Let me see if this one is correct. Yeah, see here I have these definitions here.
Okay.
So I'm going to download this, and then we can compare with your version. Oh, here we go. You guys, it's much better to organize in this way. So I'll copy this, and I'll move this to your place. Let's see, it should be here. Here, should be 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 here, and then here, I'll just paste it here. Right. So let me, because I did this, I did the calculation with this one, so let me show you this. Right. So let's see. So if I try to explain this, we really should add comments to the, well, there are some comments here. Let's just start to see. Let me make this bigger so you can see that. So we have this. If you can't hear me, let me know. I can try to improve the sound. But okay, so let's see. If I go down, it's been some time since I looked at this. So, all right, so let me run it. I think it's still running. All right, there we go. So if we look at plots, so I get these plots. These are the plots. These are the standard deviations of the combined estimator. So this is the plots you did before were the means, and these are the standard deviations. So you can see that they do have this shape here.
Yes.
So that's all fine. Now let's see. I need to remember what, because it's been some time, I need to remember what I asked you to do. Let me see. Okay, let's see. Let me see. All right. So, well, let me look at your, I'm going to clean this and let me see what you did. Let me see if you did the same thing.
No, there is no the.
Oh, no, sorry, that's not yours. That's mine. That's mine. Yours is here. Close, close, close. Now open yours. Okay, so we run this. Okay, let's see. Right. Well, it's nice you have a legend here. I'm not sure what the two so estimators of beta. Okay, and log beta. Okay.
In this equation, we have the curve is the standard of.
Okay.
The standard deviation of the beta, and the lines is a standard deviation of the vector x sub n and x sub m.
Okay.
And the color is about of the section of the beers.
Okay.
The name of the beers. The name of the beers.
Okay. Yeah, I see that these ones go here. I see that. Let me see what you're doing here. So let me look for your plot statement. All right, so here we got so you're plotting the standard deviations. That's good. And you have, okay, yeah, so those are the ones straight across, I see, and you're doing according to the color. I decided later it's better to just put, because this one here is always the same level as this one. So you just put a star here. And the other one, it's always the same level as here, so you just put a star there.
Okay, I changed that.
Yeah.
I will change.
Well, I think you should use my code because the organization is better. So it's,
yes.
Yeah. So this is like yours.
Yeah.
But it's not. They're not all on the same axis. So let's see.
Yeah.
I mean, the only difference is the plot. So let's see. So we have this. No, you did. So I think you did do. You must have done a different. You must have done a different region. Let's see what region you're doing. You must be doing, let me see what region you're doing. I think you're just doing, well, let's see. So where's the plot function? Okay. So I'm going to go here to find out what you're doing. All right, so you do it here. So let's see. Okay. Oh, so you called SB. This is inside the definition of SB. So let me look for SB. Okay. And oh, here we go. So you take SB of Dick. Okay. So this is where you call the function. All right. Now, so if I run this, let's see what I'll do the debug here, and it should come up. Is it here? Where's the code there? I think I have to do continue. For some reason, it seems it's stuck. I'm not sure why it's not continuing. Oh, maybe is that the problem? Let me stop. Stop. And I'll do this again. It looks like it has some problem defining the arrays. Let's try this again. I'm just going to put a breakpoint here, and I'll run again. Let me try again. I'm not sure why it's not working. I'm going to put a breakpoint here. All right, there we go. So let me step over it. All right, so it looks like it's okay, and continue. Okay, and then continue. Let's see. Oh, I think maybe I can't find the data. Let me see if I have the data in the right place. So I'm going to stop here. Let me see if I have the data. Yeah, because my data is not there, so I have to find it. Let's see, where's the regions data? I'm not sure where the regions data is. Here, I can find it here.
I don't remember.
Okay, there it is. Well, it's there. It's inside consistency.
Yes.
So let me see. I'm not sure why I didn't see it there.
Maybe the extension of the file.
No, it should be the same. It's in the right place. Maybe I need to set maybe I need to set the source. Yeah, I see. If I do all files, then it will do. If I look for all files, it will get there. There it is. Yes, there. Okay. Let's see. Now, I do have pickle there. That should be there. Let me just take this command and see if it can do it. That's funny. It doesn't. All right, let's look at regions then. See if my regions is in my variable explorer. All right, let me clear this. Okay. And I'll run it again. Whoops, sorry. Pickle, oh, I have to do that. I have to import pickle. So, import pickle. I ran the whole cell. I just want to run this. All right, so let's try this again. Stop. Let me remove and run again. So it's there. Let's see if it works now. All right, it works fine now. I don't know why it didn't work. All right, so let's see. So I'm going to go down. Let me just continue. Just continue step by step. All right, so here it's going through all the site names and it's creating a dictionary.
Yes.
And then it's putting it's creating this dictionary. And this is all fine.
Yes.
Okay. So let's continue down to the breakpoint. And now why is it stopping? I don't know why it keeps stopping like this. It's not. It keeps. I'm not sure why it's doing that. It should go to the next place, but it's not. It's not going to the next place. It may be something to do with the structure of the code. I don't know. Let me just stop this and we'll try again. I'm not sure why it's doing that. Let's try again. Okay. So I'm just going to do step, 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 step,
Yes.
step, step, step. So it's going to go through. Okay, wait a minute. It looks like it has a problem with this. Looks like it's having a problem with this one.
Okay.
I'm not sure why. Oh no! Finally it went. Okay, finally it went. Okay. Let's go it again. I don't know why it takes so long to do that one. It shouldn't take so long. What is an iter? An iter must be very big. That must be the issue. Oh yeah, it's very big. I see. I see. That's why it's so big. So let's make this smaller so we can run it. I'll just do 100 this time. All right. So this should be a lot better. So, and then we'll save. And then I'm going to remove the breakpoints. And then I'll put a breakpoint here. So this is where we call dictionary. Right. So let me run this again. I'll start the debugger here. Start running for the beginning. Okay, now it goes directly here. That's fine. Now let's see what Dick is. So Dick is what? This is Dick. Does it say which region this is? Does it give the name of this region?
Is a name or is a region but that we obtain in some form. So I used it to verify the question work.
Okay, yeah.
Correct.
I think that Dick must be the last one. It must. So if we.
I think that is a Bellavista.
I think it may be. I think it may be Finca. If you look at Finca
okay.
here we have AX is 0.0266. Because you did the entire loop, it should be the last one.
Maybe not is a Finca because the number of the beers is 6, but in the Dick the number of the beers is 4.
Okay, so let's see where it would be. Then should be. So you Bella Vista. Okay. All right. So yes, it's Bella Vista. It is Bella Vista. I'm surprised because it should be the last one, but it's fine. It's fine. Okay. Okay. All right. So I think this is fine. Well, so you do have different colors.
Yeah.
Okay, that's good.
I use different colors for different beers.
That's good. That's good. No, I think that's fine. Yeah, and you can do the same for both. So I think
will change this part in the new code that you make.
Yeah, I think so. If you notice, I put the plot inside the loop, so it will do all of them. I also put so you see that this loop here will do all the regions one by one. And yeah.
I want to put the name of the regions in the plot, but I have to, and I see to how to put this name. So if I can do this, I make in the code that you make.
Yeah, in fact, you can see that this site will be the name. So if I run this one, and let me put a breakpoint there. If I run this one, all right, you can see that this site is Bombascaro, and it will go through all of them. So that you can use that in the plot. Now I also, in fact, the means are not so interesting. So I have a plot means variable, and here plot means is false. So this time it will not plot the means, it will only plot the standard deviations. But yeah, but the problem with mine is that this color is always the same, and it's better to have different colors. And the other problem is that this is plotting a different. It plots the different birds on different axes.
You can move the line on the sign line 16.
Okay.
And you can.
Oh, okay.
You can
sure.
remove the space and the.
Right.
No. Remove no. You can delete the space and the plot X level is the same level for in the for. You can erase.
Well, I think all I need to do is move this. I can move this back, but then they're still all the same color. How come it's doing that? It should do more. It should be at the same.
Yes.
Is that the same level?
No.
It's not correct.
No, it's the same. And we can put a vector with all the names of the colors that we want to.
Okay.
Before no.
Yeah, I saw you have. Yeah, I see you have color. Yes. Okay. So where did you define color?
Color is the vector of color is in the beginning of the function.
Okay. Very good.
And this.
Okay. All right. So you need this also colors.
No. In the beginning of the function.
Okay, I see. Okay, right.
Vector.
Okay, very good. There should be a way. Well, there should be some kind of vector that we can use, but this is okay. So if I do that,
and we can put before and after the line if plot means.
I guess you have to put that way up here.
Yes, I can put in this. Yes.
Yeah, it's not necessary to put it inside the loop. So I can just move this here. Okay.
And
right. Now, how come it's doing that? Because sorry. Okay. Right. Okay. So then I go down here and I'll change this one. This is going to be a color.
No. You can remove the comillas.
Oh, you have to say COL. Okay. Is it like that?
Color and.
Oh, is it COLOR?
Color.
Oh, you don't put anything. I see. Okay, I see. And then here yes. Okay.
Okay. Yes.
And these I can probably just keep the same.
It's the same.
We can. And here, in fact, we can say this would be combined estimators, and then you can put 4, and then here I can put. Let's see. I have to concatenate strings. I think I just do plus. I don't remember how to do this. If I look for concatenate. Okay, let's see. Well, they just say don't. No, it's just plus. Okay, it's just plus. Okay, fine. So that's easy. So this would be, and then you just do plus, and then there's the region name. This site. And I need a space here, or there won't be. Okay. Move this out. Okay. And then let's see, where did I just put that? Where'd it go? I'm sorry. Let me make this bigger. I don't know if I did this correctly. Let's see. So I think I have to click in here. Okay, so let me. Okay, yes, okay. And then And then here, this is too long. And then I can copy this also.
And we have to change in the line 72 for the
Okay.
color K.
Okay, yes. This one here. Yes, okay, good. This one should be. Okay. Okay. And in fact, this label is not good.
And we have to move the plot X level, Y level, and legend, and plot show.
Yes,
So
yes, okay, yes, good. I think I can just do this. Where's the tab? Okay. Is that the same level? I guess so.
Yeah.
Right. Now, but this label is not good. You have to change this because otherwise it will be. I don't know what the bird names are. Does this have bird names in it?
Yes, I put in the bird names.
Oh, bird names. Okay. Yes. Okay. So I can. So this should.
Because in the function I put the variable, the vector of bird names, and change that K.
So this should be. So you have bird names. Let's see. Where are the bird names going to be? Actually, it's going to be because it's Dicka bird names.
Yeah.
So we can say B birds is equal to Dick of bird names. And bird names. So this would be here. The label should be.
In the combinate estimates, I put in this level the bird names. In the other, I don't put the level. I delete the level. The
label. Okay. I see. So we don't want the. We don't actually want these. So this would be these birds. Okay. So I take this one. I can take this one off. There, in some cases, it may be too. There may be too many birds. And same thing down here, right? This should be.
Professor, can you wait me a minute,
Sure.
please?
Sure.
Okay, Christopher.
Okay, good. So yeah, so I'm going to comment out all of this section in overleaf, because I think this was some theory, but I don't think the theory works.
Okay.
So let me.
Because I will just I saw how to compute this equation about the minus square zero.
Yes.
With this value,
Right.
this equation that beautifully.
Right. And then this one here should be. I'm not sure if we want this section or not, but that section I think we already have. So I'm going to comment this, and let me run again and make sure. Because here we already have the. Yeah, here we already have simulation of combined estimate. And then let's see. And then here again. Yeah, I think also this section, because you see I have two of them. This one says simulation of combined estimate.
Yes.
And this says the same thing. I think it's the first one that's the newer one. So I'm just going to comment all of this. So I think it's correct now. Okay, so if we go back to Python, I think this may be ready to show. All right, so it finished.
Yeah.
Now, all right, yeah, it does seem to be working. So this one is Bella Vista.
Yeah.
This one, so this is not, well, I guess here I go down. All right, this is Bella Vista. Kajuma. Well, that doesn't, this one is Finca. So you can see the best estimator is usually between 0.4 and 0.6.
Okay.
That's the best
Yes.
estimator here. For this one here, then it's interesting, the best estimator is down here. But this estimator on this side is much better than this one. This one doesn't do anything. I think there are not enough birds, only 2 birds. This one, Finca, this one. Yeah, again, that's the best for this one. This is the best for this one. It's interesting here that in this case, this estimator is better than this one. Usually this one should be better than this one. But it looks like in some cases, this one here is better than this one, which I'm surprised about that. Same here, it looks like some of these are better on this side than on this side. So I'm very surprised about that. I'll have to think about why that is. In this case, they're about the same. But it's still showing in the middle is better. In the middle is better. Oh, I think I know why it's better. So, all right, so this here, okay, so these will show us the different, well, it looks like it goes around and around again. I think this is actually okay. If I could make this bigger, it would still not be too, actually, I think I can make a new window, but that's okay. Well, this is fine. And then this is, so this is without the logarithm. So you need to do the same thing with the logarithm. I think you just copy your other code. Or you can just copy this code and do for logarithm. So logarithm will be very similar.
Maybe we can put this line as a function.
Sure. Let's see. But well, yes, that's right. Yes, you could. This whole section here. Sure, you can do that. This part here, yes, you can do as a function. Sure.
Yeah.
That would be good. That would be very good.
Yeah. Yeah. I can change this.
Yeah.
And I want to know that how to calculate the unbiased estimator of the estimators that we have of beta and logarithm of the beta.
Okay. All right. Good. So the way you show the bias is like this. In fact, I didn't do this. I can do plot means equals true, and I'll do plot standard deviations equals false. All right. So let's look at this one. Maybe I should do a few more. 100 maybe a little bit. Actually, I think 100 may be okay, but okay. Yeah, well, yes, it's fine. You can just join the same Zoom meeting again.
Yeah. Okay.
So I can send you the link again if you need it, but I think the link is in WhatsApp.
Okay.
The link is in your WhatsApp. I'll join also. Copy. Are you able to join again?
Yes.
Okay.
I'm waiting for you to
Okay.
start the meeting.
I did start the meeting for some. Oh, there we go. Okay. Yeah. I guess it just takes a little time to. So. Okay. I think you can see the screen. Can you see the screen?
Yes.
All right. So now I plot the means instead of the standard deviations. And if we look at that, all right, so here are the means. So what this is showing, in fact, is that there's no bias because the lines are straight across. So there's no bias.
Okay.
So that's good. There's no
Okay.
bias. So you don't need to do another calculation. This shows that there's no bias
Oh, okay.
because the mean does not depend on which estimator you use. They're all getting the same mean. So that means that there's no bias. If the mean of this one was different from the mean of this one, then there would be a bias. Let's see if that's true for all of them. There's a small difference here.
It's more different because you remember that I plot before of the meaning is low difference, so that it is not a line, it's not a constant, it's a line that we have some difference in the beginning and the ending of the line.
Well, that may be when you have the number of iterations to be small. If you set the number of iterations to be small, then or like if I do 10, something like this, then you'll see that there's some more difference. You see, there's more difference with a small number of iterations. And also, I think that if you look at your plots, look at the scale here. You may have seen them very different, but if you look at the y scale, the difference is not big. But if I increase this number, if I increase the number of iterations, if I increase to 1,000, then all the difference will disappear.
Yes.
Just almost the same. Very, very small difference. So that takes care of the bias. Now, what's the next thing we need to do?
Yes.
The next thing. This model. When this model generates the data,
Christopher, you record the meeting?
Yes, it's still recording. I never stopped it.
Okay.
I never stopped it. So let's see. So in this model, I think it's under SIMM. I think that's where it was created. Yes, I think it's here. So let's go to definition, which is here. Let me make this bigger. Okay. This is where we simulate this is where we simulate. The thing is that we take Pn equal 0.7, but in real life we don't know Pn. We'll have to choose Pn to be something different. In fact, Pn will be different for every different bird. Pn will be different for every different bird. So I will have to change this. I'll have to change this definition to introduce. So I want to introduce a random factor into this. Whoops. And how to do that?
This random factor is in the interval 0 until 1.
Well, no, it's going to be. It has to, because Pn always has to be a positive number. Oh wait,
Okay.
That's right. This Pn is not correct. Because in the empirical we found Pn is something different. Let me go back to the. Let me go back here. We found Pn was something like a negative number, not a positive number. And there are some tables here. Actually, I think it's this one here. I think it's this one here, but I have to make it bigger somehow. Or I can open the picture. I can open the picture. Okay. Oh, sorry, that's not what I want. Not these. Let me just keep. Oh, that was it.
Okay.
Okay. Well, that's the error. Well, let's see what that is. But okay.
In the object, we have some table about the Pn.
Oh, okay. Yes. Okay, that's right. Okay. Let's go back and see. Where would that be? Well, here, let me get this back also. I want to be here. Oops. So where's the, so I guess I can just look for table. There's no counter here. Right here, okay. Yes, okay, yes. I want to jump to the, where's table one? Oh, it's down here, okay.
Yes.
Yes, okay. Yeah, so usually it's negative. So that's what we would have to do. We would have to do a different, we have to do different PB for each, that's actually the first thing you can do, is we will want to make, in fact, this shouldn't be PN, it should be, it should be PB. Well, PN is okay, right? But what, so, the first change you have to do is make PN depend on the region.
Okay.
So according to table
The
one.
table.
Yes.
Okay.
So we can do that. I think actually you should add, so I think what you should do is you should add a PN, or you can say PV, to the dictionary.
And this PV is random.
No, this PV, this
according to
PV,
the region.
this PV you should use these values.
Ah, okay, okay.
But so later we'll add a random factor to PB. And I think the way you create a random factor, it would be, let's see, so I'll just say, just call this, I just call it EPS for epsilon. And this is going to be equal to, I guess, because we need to, I forget how to do this. With NumPy, I want to find a random normal variable. Okay, NumPy at random normal.
Yes.
And then this is the mean and this is the standard deviation. So this would be, and then this is the size. Okay. So this would be np.random.normal. And then the mean is going to be 0. No, all right, sorry. EPS should be a small number. But first I'll make EPS to be equal to, it's just equal to 0.1. And then here we do NP, so this one is going to be, PN is going to be different. So PN will be equal to, I'll just put 0.7 for now. But then then it's going to be EPS, and then the number of them. The question is, how many of these do we have? I guess it's n, because n is the number of birds. N must be the number of birds. Yes. Okay. So this would be n. So we have a different one for each bird. And I think that may work okay. I think that may work okay. All right, so you need to add this PB to the regions dictionary. So,
Okay.
So here you'll have to replace with a PB from the regions dictionary. Okay, so we both have to make the PB depend on the region and add some random something. We can run this and see if it works. I'm not sure it's going to work. It may not work. Oh, it worked. Okay. That's interesting. It did work. And these are the means. And the means still work. Let's look at the standard deviations. Let's look at the standard deviations. So I want to do this one to be true. And this one can be false. And let me clear my plots. Okay. And let's see what this does.
I have some, it's not that much different.
Well, but these, I think the green one should be higher. What should happen is the green one should be higher. I think the green ones are higher than before.
Maybe.
It looks like they're, well, yeah. If I increase that EPS, it should be even bigger.
Okay.
Let me see if that works. Where did I put EPS? I guess it's here. Right? I'll just call this 0.5. That should make it quite a bit bigger. Let's see if that does something. Yeah, it doesn't look like, you're right, I think it's not changing very much. I don't think it's changing very much. So there may be something wrong with the, because this one here looks the same. Yeah, it's not changing very much. So I don't know what's wrong.
I will review the code and I change that I have to make.
Okay.
And I send you the,
Okay.
no, not send you, I upload all the Dropbox.
Sure, that's the best thing.
So if I have some question, I call you.
Sure.
Or I write you.
What's up is fine. Sure.
Thanks for the meeting.
Okay.
And can you
I'll send you the recording. Yeah.
Yes.
Okay. All right, good. Very good. Yeah, call me. Yeah, send me WhatsApp anytime.
Thanks.
Okay. Sure.
Thanks.
Okay. Okay. All right. Bye-bye.
Bye.
He is from Ecuador. Yeah. She's Benicia student.